Today we are looking at Chebyshev's theorem. Chebyshev's theorem is another way to look at standard deviation. The difference between Chebyshev's theorem and the empirical rule is that the empirical rule is used for a bell-shaped curve. Okay? When we have symmetric data, that bell-shaped curve, we said 68% of the values were standard deviation from the mean, 95% of the values were 2 standard deviations, and 99% of the values were 3 standard deviations from the mean. But with Chebyshev, those percentages are going to be a little bit different because of that skewed data. So when we look at Chebyshev's, the key variable is going to be k, and k just represents how many standard deviations you are from the mean. And the formula that we're going to be using for Chebyshev is that if we want to find what percent is away from the mean, okay, then we're going to use the formula 1 minus 1 over k squared. So what that means exactly is if you knew that your data was 2 standard deviations from the mean, if we substitute that into our formula, 2 squared, k squared, is 4, so 1 minus 1/4 would be 3/4. And we know 3/4 represents 75%. So in Chebyshev's theorem, 75% of the values are always going to be 2 standard deviations from the mean. That value never changes. So k equals 2 is always going to be 75%. If we were 3 standard deviations from the mean, then again, if I use my formula, 3 squared is 9. So I have 1/9 here. 1 minus 1/9 is 8/9. 8/9 is roughly 89%. 89% of values are always going to be 3 standard deviations from the mean. So these are the 2 most common percentages we use in Chebyshev's theorem. But if we had to find another value, okay, k doesn't have to be an integer. I could put in 2.5. I could put in 1.5. What I can't put in is 1. Okay, so Chebyshev starts after 1 standard deviation from the mean to find the actual percentages. But again, these numbers are going to be important because they come up very often in Chebyshev. Now, we have some examples here. And in the first example, okay, we're told that the mean price of a home was $150,000 and the standard deviation was $10,000. And the first type of question they could ask is, what is the price range for at least 75% of the houses? So they're telling us the percentage, we want to find the range. And what you have to recognize is this is the key part. This is why this is boxed in. When it says at least 75%, that's your hint that we're 2 standard deviations from the mean. So if we're 2 standard deviations from the mean, there's 2 ways we can do this problem. We can do it as a formula, where we say the mean plus or minus 2 times the standard deviation. Okay, so the mean is 150,000. 2 times the standard deviation of 10,000 is going to be 20,000. So if you add 20,000 to your mean, you get 170. If you subtract 20,000 from your mean, you get 130. That's the price range. If you're 2 standard deviations away, 75% of the houses are going to be in that price range. If you wanted to do it graphically, okay, the mean is 150,000, so standard deviation is 0. If I go 1 standard deviation away from the mean in both directions, I'm going to add and subtract 10,000. If I go 2 standard deviations away from the mean, I'm going to add and subtract another 10,000. I still end up with 130 and 170 for my answers. Okay, so we could use the formula, or some people like to do it out visually. Doesn't matter how you do it, just as long as you can find the range. The second type of question we can have in Chebyshev is the opposite of what we just did. Now we're trying to figure out the percentage. Okay, find the minimum percentage of the data values. Okay, what we were given in this problem is that 25 cents a mile is what they're allowed for travel allowances. So the mean is 25 cents, and we're told that the standard deviation is 2 cents. And what we want to know is, if you fell between 20 cents and 30 cents, what percent of the population would that be? So formula-wise, okay, to figure out our standard deviation, we're going to take our sample mean minus our population mean and divide it by the standard deviation. So if you took 20 cents minus 25 cents and divided it by 2 cents, you would come up with a negative 2.5. And if you do the same thing with the higher value, you're going to come up with a positive 2.5. These will always be symmetric. Okay, they'll always come out to be the same value, just one positive, one negative. So if you know K is 2.5, then we're going to go back to our formula, find out the percentage. Okay, the one that we did on the first page. 1 minus 1 over K squared. So 2.5 squared is going to be 6.25. 1 divided by 6.25 is going to be 16%. So 1 minus 16% is how we come out with 84%. So 84% of our values, okay, are going to fall within 2.5 standard deviations of the mean. So that's the way we can do it by a formula. The other way that we can do it is we could, again, do it out on a graph. We could show it visually. Okay, my mean is 25 cents. If I go 1 standard deviation away, I'm adding 2 cents in both directions, or subtracting. Okay, and if I keep doing that, what you're going to find is that 30 cents falls between 2 and 3, and therefore that's why you know K is 2.5. So formula or visually, you're going to see K is 2.5. Once you know that, you use the formula to come up with the percentage to find your Chebyshev. And then the last two examples that we are going to look at, okay, our mean is 80, our standard deviation is 10. At least what percent of values will fall between 60 and 100? So again, we want to find the actual percentage. So I used the formula this time. I said, all right, 60 minus 80 divided by 10, K came out to be negative 2. 100 minus 80 divided by 10, K came out to be positive 2. So again, those are going to be symmetric. So we know that if K is 2, that's one of our knowns of 75%. Again, if you had forgot that, you could use the formula. And if you use the formula, you can see it comes out to be 75% of the values. If we were to be between 65 and 95 with a mean of 80 and 100. Okay, again, if I use my formula, I come out with a negative 1.5 for K, and if I substitute 95 in, I come out with a positive 1.5. So if I'm 1.5 standard deviations from the mean, using my formula, 56% of the values are going to be 1.5%. Excuse me, 56% of the values are going to be 1.5 standard deviations from the mean. Okay, 2 standard deviations from the mean, always 75%. 1.5 standard deviations is going to be 56%. And then for number 4, okay, if your mean is 72 and your standard deviation is 15, find the range in which at least 75% of the data will fall. Again, key phrase, at least 75%. That's telling you that you are 2 standard deviations from the mean. If I do it visually, okay, the mean is 72. I'm going to add 15 each time, subtract 15 each time. I end up with a range of 42 to 102. If you use your formula, 72 plus or minus 2 times 15, 72 plus 30 is going to be 102. 72 minus 30 is going to be 42. Again, you're going to come out with the same answer each time. If you're comfortable using the formula, use the formula. If you need to show it visually, okay, you can do it that way. But basically, those are the 2 types of questions that we're going to have with Chebyshev. You're either going to be finding the percentage values, okay, what percent is going to represent the standard deviation that you found, or if they're given the percentage, they're going to ask you, okay, what is the range of values? Okay? And again, we'll be talking more about this in class.